Hi, let's take another look at an additional acceleration problem. So reviewing our formula, we have acceleration, remember, is equal to velocity final, and that little sub f, remember, is final velocity, it's another way to say it, minus velocity initial, so it's differentiating between the two velocities, what's what, divided by time. All right, so let's take a look at this word problem. A roller coaster is moving at 25 meters per second at the bottom of the hill. 3 seconds later, it reaches the top of the next hill, moving at 10 meters per second. What is the acceleration of the roller coaster? Now, first of all, let's think this through. If we're starting at the bottom of a hill at 25 meters per second, and at the top of the next hill, we're only going 10 meters per second, you should be thinking in your head that we are slowing down. And negative is the term we use for an acceleration slowing down. We can say decelerating, but science doesn't really like that. We like positive accelerations for going fast and negative accelerations for going slow. So let's label this. A roller coaster is moving at 25 meters per second at the bottom of the hill. That's my initial velocity. 3 seconds later, that's my time. It reaches the top of the next hill. It's now moving at 10 meters per second. So now that's my final velocity. It's always a good idea to label the different parts of a word problem. It kind of gets rid of all the extraneous information that you don't really need. You're just identifying the main points: initial velocity, final velocity, and time. So let's plug this into our equation. We have A equals, and we could go over here and do that, but we'll do that in just a minute. Let's plug this in first. Final velocity is 10 meters per second minus initial velocity 25 meters per second and divided by time, which is 3 seconds. All right, now let's go and make this official over here, because remember, on this I'm asking you to identify the different parts and then actually tell me what the equation is. Final velocity is 10 meters per second, initial velocity is 25 meters per second, and my time is 3 seconds. Now it's simply taking those three variables and plugging it into the equation. So in this case, acceleration is final velocity, your 10 meters per second, minus your initial velocity, 25 meters per second, and divided by 3 seconds for time. Now all that's left is for us to solve this problem, right? So let's do that. Well, what is 10 minus 25? So I'm going to actually do a little intermediate step here just to make sure we're getting our sign right. Well, 10 minus 25 is a negative 15 meters per second. Now we need to divide that by 3 seconds. So a positive divided into a negative is still a negative, right? So we have a negative number. 15 divided by 3 is 5. And remember, we did that fancy multiplying by the reciprocal, and we end up with meters per second squared, or meters per second. Either one is fine. And it's easier on this part. In answers, it's hard to do superscripts, so we just do meters per second here. So the answer is negative, so be careful, I've got a positive here, negative 5 meters per second. And it's yelling at me because I didn't select that first. All right, if you have questions, as always, make sure you're coming up and asking me, or you're jumping on Zoom, depending on however you are seeing this.